Friends, welcome to Bank Exam Cafe, and in today's episode on Let's Revise 5 marks questions on complete syllabus. This is the part 6 and this is the part 7, and we are going to see few more questions of 5 marks. And these 5 marks questions will be asked in the section 5. Previously we have uploaded 6 parts, and the links of all these 6 parts are provided in the description box in the PDF format. Download that PDF and watch all the 6 parts to know that which type of questions will be asked for the 5 marks questions and how to deal with such questions. Also download the other study material from the description box. So friends, let us move to the question. Friends, here is a question on the screen. In the figure, O is a point in the interior of the triangle ABC. O, this is a point in the interior of the triangle ABC. OD, OE and OF are the perpendiculars drawn to the sides BC, CA and AB. Here it is OD is perpendicular to BC, OE is perpendicular to AC and OF is perpendicular to AB respectively. Show that AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square. Friends, here we want AF square and this angle is given as 90 degree. And if we get this as a triangle, then this will be a right angle triangle and there you can get AF square. So first what we will do, we will join OA. So do the construction, join OA. Similarly join OB and join OC. Now here you see that in triangle AFO, in this triangle, this is a right angle triangle and so we can apply the Pythagoras theorem. So in this triangle we can write that AO square is equal to AF square plus OF square. So first I do write that much. So here in triangle AFO, what we get? OA square, square of the hypotenuse. The side opposite to 90 degree is hypotenuse. So OA square, that is equal to OF square plus AF square. OF square plus AF square by Pythagoras theorem. Similarly, we can take this triangle BDO. In triangle BDO, this is the first triangle we have taken. Now we are taking the second triangle, that is triangle BDO. So in triangle BDO, here this is the hypotenuse. So square of the hypotenuse, that is OB square, which is equal to sum of the squares of the other two sides, that is BD square plus OD square, BD square plus OD square, and the reason will be the same Pythagoras theorem. And now here in triangle, this we will take as the third triangle, that OE square, because this is 90 degree, this angle will also be 90 degrees. So this is the hypotenuse. So OC square is equal to OE square plus CE square. So in triangle CEO, we have OC square is equal to EC square plus OE square. Again the reason will be the Pythagoras theorem. Now here from this we get AF square is equal to OA square minus OF square. Therefore we get AF square is equal to OA square minus OF square. Similarly here what we require, BD square we require, so we can write as BD square. If you take OD square to this side, you will get BD square, which is equal to OB square minus OD square. And similarly here we want CE square, so CE square that will be equal to CE square that is equal to OC square minus OE square, OC square minus here we are taking is OE square to this side, so it will be OE square. Now let this be number 1, let this be number 2, and let this be number 3. So here what we want, AF square plus BD square plus CE square. So if you add all these three, you get AF square plus BD square plus CE square. So we will add equation number 1, 2 and 3. So adding 1, 2 and 3. So if you add all these three, you will get it as AF square plus BD square plus CE square, which is equal to here OA square minus OF square, OA square minus OF square, then OB square minus OD square plus OB square minus OD square plus OC square minus OE square, OC square minus OE square. Now here, see this already we have got the left hand side. Now check the right hand side. Here if you see that OA square minus OE square, look at the figure, OA square minus OE square, correct? This is also a right angle triangle, and therefore the square of the hypotenuse is equal to sum of the squares of the other two sides. So it will be OA square is equal to OE square plus EA square. So same you will get as OA square minus OE square, that will be equal to AE square. So this can be replaced as AE square, correct? Now similarly, if you see another, what we want here, CD square. So where do we get CD square? CD square, correct? We get in this triangle, correct? So here if you apply, you will Pythagoras theorem, you will get OC square minus DC square. So OC square minus OD square, this is OC square minus OD square, that will be equal to CD square. So this we can write as CD square. Now here what next we want, BF square, so BF square, how you will get this BF square? It will be what, OB square minus OF square. So OB square minus OF square, that will be equal to OB square minus OF square, that is equal to BF square. So plus BF square, and that only we have to prove. Therefore AF square plus BD square plus CE square, which is equal to AE square plus CD square plus BF square, and hence it is proved. Here you will have to write the answer that all this OA square minus OE square is equal to AE square, OC square minus OD square is equal to CD square, and OB square minus OF square is equal to BF square. That reason you will have to write here by Pythagoras theorem. Friends, here is a question on the screen. In the figure, angle BED is equal to angle BDE. This angle D and angle E, these two angles are equal, and E divides BC, this E point that divides this BC side in the ratio 2:1. It means BE upon EC. This ratio is what? This ratio is 2:1, and we have to prove that AF into BE, AF into BE, that is equal to twice of AD into CF, that we have to prove. Now friends, if you look at the figure, you will see that there are no parallel lines, nothing else. So we cannot apply basic proportionality theorem. There is no right angle triangle, so we cannot apply Pythagoras theorem, and therefore we will have to do some construction. So we will construct CG, this CG such that this CG is parallel to DE. So DE and CG will be parallel by construction. And so first write that construction, draw CG parallel to DE. Now we will take this triangle. In triangle BCG, in triangle BCG, here in this triangle we see that DE is parallel to GC, DE is parallel to GC by construction, and therefore here we can apply the basic proportionality theorem, that BD upon DG is equal to BE upon EC, and therefore BD upon DG, that is equal to BE upon EC by basic proportionality theorem. But BE upon EC, this BE upon EC, this ratio is what? It is 2:1, and so this will be 2/1. So BD upon DG, which is equal to 2/1, because this ratio is given as 2/1 because BE is to EC, that is equal to 2:1, that is given. And now this we can solve further, as if you take DG to this side, you will get DG, that is equal to half of BD, correct? So we have got DG is half of BD. This DG we have got half of BD. But if you see here in triangle DBE, these two angles are equal, and therefore the sides opposite to the equal angles will also be equal, and therefore BD will be equal to BE by reason the sides opposite to the equal angles are equal. But in triangle, here we can say that but in triangle BDE, we can say that BD is equal to BE, BD is equal to BE, and sides opposite to equal angles, correct? Sides opposite to equal angles, and since BD is equal to BE, we can replace here BD by BE and we get DG. Therefore DG is equal to half of BE. DG is equal to half of BE. Let this be equation number 1. So what we are getting, DG is half of BE. Now we will take this triangle, correct? In triangle ADF, in triangle ADF. Now here we have seen that CG is parallel to DE by construction. Since CG is parallel to DE, it is parallel to DF also, and therefore CG is parallel to DF. The reason is what? It is construction. And therefore here we can say that AD upon DG, I write it here, AD upon DG, AD upon AD, this AD upon DG, which is equal to AF upon CF, which is equal to AF upon CF. Reason, corollary of basic proportionality theorem. So this is because of the corollary of the basic proportionality theorem, that AB AD upon DG, that is equal to AF upon CF. Now here we will cross multiply. So AD multiplied by CF, that is equal to AF multiplied by DG. Correct? Here we have cross multiplied. Now if you look at here, we got DG is equal to half of BE. So DG is equal to half of BE. We can replace here. So AD multiplied by CF, which is equal to AF multiplied by half of BE. Now take 2 to the other side. So if you take 2 to this side, it will go to numerator and you will get it as 2 into AD multiplied by CF, which is equal to AF up into BE. And that is nothing but AF into BE. AF into BE, that is equal to twice of AD into CF. That only we have to prove, and therefore hence it is proved.